Good day, respected judges. My name is Verawaty Binti Ismail from the Mechanical Engineering Department, Politeknik Tuanku Syed Sirajuddin. Today, I will present our innovation project titled Design and Fabrication of a Small-Scale Crucible Furnace for Aluminium Melting Practice in Foundry Workshops. This project was developed together with my team members, Technologies Choong, Mohd Hilmi bin Ariffin, and Technologies Dr. Choong Chee Guan. Foundry technology uses heat to melt and cast metals into finished products. This process enables the production of complex metal components used in industries such as automotive, aerospace, marine, and manufacturing. As a key component in foundry operations, furnaces provide the thermal energy required for metal melting, making them essential equipment in metal casting applications. However, our foundry workshop faces several major issues. First, commercial crucible furnaces are extremely expensive, costing around Rm 70,000. Second, the current furnace requires 1 to 1.5 hours to melt aluminium, reducing teaching efficiency. Third, the furnace has excessive capacity for student projects and requires high maintenance costs. Therefore, a smaller, more affordable, and portable furnace was needed. Thus, the objectives of this project are to develop a small-scale crucible furnace for casting applications, to construct a portable lift-out crucible furnace for melting metal, and to evaluate its melting efficiency during operation. The furnace was designed as an LPG-fired crucible furnace using a high-pressure burner system. It consists of a drum barrel outer body, refractory cement lining, and ceramic fiber insulation to enhance thermal retention. The furnace is lightweight, portable, and capable of melting 5 to 10 kilograms of low-temperature metals such as aluminium. This flowchart outlines the furnace development process, from design and fabrication to testing and performance analysis of the completed crucible furnace. This figure shows the technical design drawing of the developed crucible furnace, including its dimensions, structural layout, and 3D assembly view used for fabrication. This figure shows the fabrication process of the project from start to completion. This figure shows the setup, overall structure and main components of the developed crucible furnace. The melting and pouring process involved heating LM6 aluminium alloy in the crucible to 800 degrees Celsius, monitoring the temperature every 5 minutes, and then pouring the molten metal into the mold for casting. Performance evaluation was conducted by monitoring the temperature of the molten metal, furnace wall, and furnace cover during the melting process. Results show that the furnace successfully melted aluminium within 35 minutes, reaching 871.8 degrees Celsius. The furnace exceeded aluminium melting temperature within 15 minutes, demonstrating efficient heating performance. External temperatures remained low, with the furnace wall only reaching 50.8 degrees Celsius, indicating excellent thermal insulation and safe operation. The furnace achieved a thermal efficiency of 10.52%, based on useful heat absorbed by aluminium compared to total LPG heat input. One of the major innovations of this project is cost reduction. Commercial furnace cost, Rm 70,000. Our developed furnace cost only, Rm 662. This represents more than 99% cost savings. The following shows the innovation application letter for the implementation of the developed furnace in workshop practice, which has been successfully integrated into the teaching and learning process. The implementation involved students from the Diploma of Mechanical Engineering, DKM2B, Session 2 and 2025-2026, comprising 28 students. The lab sheet used for the metal casting process practical is shown as follows. The furnace has been successfully applied in teaching and learning for sand casting practical tasks. Students achieved 77.9% for CLO1 and 84.0% for CLO2, indicating good competency in procedural compliance and practical casting performance. This proves the furnace effectively supports foundry education. The following section presents the standard operating procedure, SOP, for furnace operation and the furnace setup guide. This project contributes to Sustainable Development Goals, SDGs, i.e. 4 Sudanese pounds quality education by enhancing practical engineering training, 9 Sudanese pounds industry, innovation and infrastructure through low-cost engineering innovation, and 12 Sudanese pounds responsible consumption and production through improved energy efficiency. In conclusion, this project successfully developed a portable, efficient, and low-cost crucible furnace for aluminium melting in foundry workshops. It improves melting performance, reduces cost significantly, enhances teaching and learning, and provides a practical alternative for small-scale foundry applications. Thank you for your attention.